going forward, I think there's a lot more things that you can think of that we want to recycle. So I think we're really at the start of movement towards understanding this area of research. We're really moving towards sustainability.
I don't think a lot of people have the opportunity to speak with somebody who's so directly involved with this type of research.
The outcome would be less plastic in landfills and more of that plastic somehow being used to make things that consumers can buy and use.
So Dr. Wang, welcome. I'm happy to have you here. I just want to start off by allowing you to give us a brief introduction about who you are, what it is that you do, and whatever else that you want to add.
My name's Clay Wang. I'm professor of pharmaceutical sciences at the University of Southern California School of Pharmacy. I'm a medicinal chemist. I study microorganisms that are responsible for making medicine. So one of the things about work is, as you know, sustainability is a relatively new idea. So most of us are funded by funded by the NIH to fund drug discovery, for example, or doing some chemical reaction funded by the National Science Foundation. Okay, so what the sustainability award allows us to do is come up with some funding to get some students to work on some sustainability research related projects. Then we can then go out to get funding from the federal government specifically that are related to sustainability, and which is what we recently awarded.
Very cool. I wanted to bring up the article about your Sustainability Research Award and just read you a little bit of a blurb that was in the article. That you mentioned that the ultimate goal is to develop a method that could be used on a mixture of plastics. Right now, if you go to recycle your plastic waste, there's only one bin, but there are actually several different classes of plastics. Twofold. How can the government or how can the community on a broad spectrum do better with recycling? And what can this do in terms of helping the pharmaceutical industry?
Okay, that's there's
It's a
several
loaded
levels,
question.
several levels to that. Okay, so in terms of the community, I think recycling rates in this country is still pretty low. So if we put an effort to put into that recycling bin, there's a lot of efforts now to take the mixed plastic waste in the bin to kind of recycle them. So that's from the community perspective. For the sustainability part for drug company and production is that historically we've been really focused on just finding ways to make molecules, make drugs, make medicine, but sustainability has not been a part of it. I mean, if you look at packaging, for example, your pills are packaged, you take your pill, but there's a lot of waste that's thrown into the trash. So there's a lot of components of sustainability in there. And we wanted to combine our research and have topics that could be helpful for plastic recycling.
Very cool. And so like what sort of significant milestones and challenges have you encountered during this research?
Significantly challenge. Okay, for us, I think we're really at the start of movement towards understanding this area of research. And I think that's not just us, but overall as a country, we're really moving towards sustainability and certainly how to recycle plastic. So much of the effort previously was on like, let's figure out new ways to make plastic a better plastic. And now that we realize those plastic are now in the landfill will last for, hundreds of years. Now there's significant effort, not just us, but in the world to try to use that, find ways to increase that recycle rate.
Got it. And I know, so actually doing research and reading more about what you've been doing and, the initiatives that you've been a part of, I haven't realized that Catalina Island, which is located 22 miles off the coast of Los Angeles, they predict that there's going to be a volume of 1.1 billion tons annually by 2040. What can you say towards that?
Okay, so I think the numbers. Let me explain a little bit.
Yes.
Okay, so that billions of plastic is not from Catalina. What it is all the trash that we collect. Okay, a small amount gets washed up to the ocean,
Okay.
and then they collect in the Pacific Ocean.
I see.
Okay, and that's not just us. Imagine Pacific Ocean. You got all the countries out in Asia, and things like that. So what happens is all this trash collects in the ocean, and they wash up together and form
Mm,
this billion, like kind of a plastic island.
around.
It's called the plastic gyre,
Hmm.
okay? And that's that trash that's collected, and not just Pacific Ocean, but several oceans in the planet has these basically collection of trash that collects in this area, and that has to do with like water currents and things like that.
Hmm.
Okay, and the reason why Catalina Island becomes involved is that Catalina Island, if you look at it, has two sides. One side looks over LA,
Yeah.
and there's the other side looks at the Pacific Ocean. And the Cat Harbor, which is where we collect our trash, that faces the Pacific Ocean. And that actually part of the plastic jar washes up to
Got it.
Catalina Island. So
Okay.
it's not that Catalina Island gets billions of
And
trash.
harbors this
Right.
trash. Okay.
It's just that we can collect that part of the Pacific Gyre. So there are actually nonprofits. They take a boat and they actually go to the Pacific Ocean and collect those trash, and they bring it back to the land, and it puts it in the landfill. But what we would like to do is we would like to create some value to the molecules that washes up that are collected in the gyre to try to make something valuable.
Okay.
Um,
That's amazing. I mean, this is something that would be along the lines of something that I would volunteer for. So we can discuss maybe later on how I can maybe venture out and maybe even just help clean up some of the plastic. But this is not a new concept, but it's still relatively new with the whole sustainability, keeping our beaches clean. We know our coral reefs are struggling detrimentally. I feel like this has a trickle down effect to that to kind of reestablish the coral reefs. But what I want to ask you is how did you get here? What
yeah,
inspired you?
so my lab here at USC, I mean, if you look at School of Pharmacy as a science,
Hmm.
it's a very multidisciplinary school. So we
Yes.
have scientists that study the pricing of economics of medicine,
Hmm.
all the way to such people like me interested in making how molecules are being made. And my lab has always been really interested in converting, finding new ways to make molecules and drugs. Okay. So historically, we were funded by the Department of Energy,
Hmm.
and the Department of Energy is
Mm.
really interested in the plant biomass and converting from plant biomass into medicine or things useful. So, um, uh, out, a logical extension of that is instead of working on plant biomass, we want to work on plastics. And what's interesting from here in Los Angeles is that um, there's actually an advantage to working with plastic because we are in an urban setting.
Hmm.
So for us, it's actually much easier to collect plastic waste than like plant biomass because there's just no cornfield that we can just walk over to the next door to collect. So in terms of research, it's just a lot easier for
Hmm.
us. Um, but it was just a logical extension. And you mentioned about coral reefs.
Hmm.
We at USC have a really large marine biology department. So as part of our drug discovery efforts, we have always worked with the marine biology department to look for microorganisms in coral reefs to look for molecules. Okay. And we always had ties with the marine department so that now we collecting plastic from the marine
Hmm.
institute is something that's just something that we've been able to do.
You spoke about the lab. Can you give us a little bit about the process? I know it's going to be a little bit nitty gritty, but
Okay, so let me explain to you. So actually think about it this way. So we work on microorganisms.
okay.
Okay. So these microbes like penicillin. Let me back a little bit. So we study like penicillium. So they make penicillin. So most people are pretty familiar. You get sick, you get infection, you take antibiotic,
Hmm.
and penicillin is one of the most famous one.
Yep.
Okay. So these microbes basically have to make penicillin with some carbon source, and they usually get it from glucose or sugar. So what we're thinking is instead of growing it on glucose, we want to grow it on plastic. Okay. So
Ah,
why is plastics not sitting in the landfill for 100 years is still there? Is because there's no good microbes that can cut the
correct.
original carbon-carbon bond.
Right.
So what we do is we take that first plastic and chemically treat them to break them up. Okay. So in terms of polystyrene,
Hmm.
we break them into benzoic acids.
Okay.
Or for polyethylene, which is your plastic bags, we break them into long carbon chains with carboxylic acid. So the chemistry breaks the bonds. Okay. The ones that are broken, it's basically a carbon source kind of similar to glucose. So instead of growing on glucose, we're growing on the chemicals that we give them. But there's
Wow.
always, I think it's very important.
Hmm.
Um, our labs at first are a hybrid approach. So
Okay.
there's a chemical steps, and the idea is chemistry will do what microbes cannot do,
Okay.
but then the microbes will then take that part and then make things. And microbes, we've been studying microbes. We've been studying fungi at USC for 20 years.
Hmm.
These things can make medicine and make all kinds of things.
That's interesting. And
Uh-huh.
then the thing about it is, so let me ask, so what is the potential does this process have on addressing the global plastic waste problem? And I know we talked about sustainability, and I feel like sustainability as the umbrella term has so many other factors that we can think about. Can you elaborate?
Okay, so the issue right now, why plastic is such a big problem, is that it's cheap to make,
Mhm.
but there's no value and it ends up in the landfill. And right now we throw away, we don't think of it as cost, but there's cost into the environment, there's space in the landfill. Eventually the landfill space is going to fill up, right? So what we want to do is we want to make things, and this NOAA grant, we're actually making the blue dyes to make jeans. Okay,
Got
so
it.
we're making
Okay.
eco fashion.
Mhm.
So what we would like to do is we want to create value to these trash. So then instead of just collecting the ocean and put it in a landfill, let's create something that has some economic value. Then that value will then hopefully entice more of the plastic to get used up. So idea is instead of just going to waste, create something that people will buy. So create some economy to
I wanted to touch back to what you said about growing these things
it.
on plastics. And does that have a twofold effect of basically, since the plastic bonds are breaking, does that make it easier for the plastic to degrade while also providing an environment to grow these substances and
Right,
create
you're
these things?
right. So what happens is we break them, right? So then there's no longer plastics. And some labs are interested in, let's just take plastic, degrade them so that there'll be precursors to be used as plastic again. But what we do is we break the plastics down and they become carbon source for our organism. Okay, so we're
Hmm.
basically trying to replace sugar.
Hmm.
And I mentioned previously we work on plant biomass. What we were doing previously was breaking down the plant biomass
Hmm.
and then use it as a carbon source for the fungus.
But that's
So
what the plastic is now doing when you
yeah,
break those bonds. Got
right.
it.
You
Okay.
understand. So it's
Yeah.
just the same thing, but now we have some value to it.
Right. That's just amazing work. I know you previously spoke about USC and
Mhm,
their extensive marine biology
mhm.
department. How can academic institutions like USC and others contribute to these community-driven solutions? What can we do as USC? How can faculty, students, administration get involved to spread the word about sustainability? How can we get active, and how can academic institutions promote that?
Okay, that's a very good question. So, um, many university has sustainable efforts, but USC is unique because we're here on the coast. So we're in an urban setting, yet we are so close to the ocean.
Hmm.
And that's what we also have besides our main campus, in our health science campus. We have an institute at Catalina Island. We have a research institute with housing and research
Oh, wow.
facility.
Okay.
So what we have is we have an opportunity to do research, but we also have an opportunity to do outreach. So people can go, students, high school students, undergrads, elementary students can go to Catalina Island and see actual experiment to be done in hand on their hands.
Hmm.
So you probably don't know this,
I don't.
but your tuition dollar is paying for a boat that goes to Catalina every day at 7:30, sorry, 8 o'clock, and arrives there at 9:30 and comes back at 5. Every day there's actually a boat that goes back and forth. And there's actually students at Catalina doing research and doing marine research in the facility.
I am very happy and I'm so glad that this is a topic of discussion because, for one, I didn't know the extensive research and sustainability efforts that were here at USC. And two, I didn't know that there were opportunities to actually see and visualize what's going on in a lab. And so, that also kind of segue into like how can students and researchers at USC get involved in initiatives that address marine debris and other environmental challenges? So how can we now start here, but then also end up here with the sustainability efforts that we're currently involved in?
Right. So I think um, for our university is to really let people know these opportunities are available. I think it's just one of these things that as we get more federal funding and we start getting more these outreach programs, then people will realize. But I mean, because for example, last week we went to Catalina
Hmm.
as a group of 15 students to go collect some plastics to come bring back to experiment.
Interesting. And so I know research like this is not without its challenges. And so I want to discuss with you what are some of the challenges that were presented when you were doing this research and how did you guys overcome those?
So this actually was a project that I was really interested in,
Hmm.
but it was not something that was the main part of our lab. So we actually took a couple years of trial and error to figure this out. It turns out for the microbes that we study, not all the substrate that we make is can be
Viable.
used
Hmm.
viable. So it took some time before we worked out which part worked. But I think this is an example where failure is just something that you learn from,
Hmm.
and it took a lot of trial and error. So
Hmm.
for a lot of students, they don't realize that you go to school, you're probably mostly A students again to USC. To be a scientist, there's a lot of failure. It's more like a
A lot.
baseball. It's more like a baseball game where there's a lot of failures, but those successes are very, very nice and sweet.
Yes, I would agree with that. I kind of liken it to the entertainment industry where they say, you're going to get a lot of no's, but don't let that be that like your determining factor. Because I feel like when you get that yes and you have a breakthrough, especially within research, it's one of those feelings that's like inexplicable. You can't really explain it. And so I kind of understand that aspect of it.
I think you're right. I think this is LA, so that's actually probably a better analogy. And I think you talk to all the movie stars, they get a lot of no's. And
Hmm.
of course, there's superstars that get all yeses, but most actors probably get lots of no's.
Hmm.
Very similar to us.
Yeah, yeah, I would say the same. I know you specifically talked about working with Dorn Seif previously. I wanted to see if you have any other or elaborate on any notable collaborations or partnerships that played a crucial role in this research.
Right. So Dornside, there's basically three partners we have. One is the chemistry department. My
Hmm.
colleague Travis Williams, who's the chemist who's developing these chemical reactions. I've known him. I've been know him for 30 years. We went to school together many times. So he's my chemistry colleague, and then I have my Wrigley Institute colleagues, which is the Sustainability Institute here at USC. Joe Arvai is the head of the Wrigley, so he and I are one of the scientists on this grant. And then the third is the Marine Biology Department, our colleagues that work with us to work on projects related to the ocean. So there's three pieces to this.
How significant, how critical, how important are those collaborations with each other? What do they provide?
Right. So if you think about this, so we need chemists to like come up with chemical reactions.
Hmm.
So our colleagues in chemistry does that. And then the sustainability, Joe and his team and the Wrigley people, they're experts on a lot of the areas in sustainability, which this is not frankly not something got my degree in. I
Right.
just learned. So they're the experts on that. So this is an example where you need to have collaboration across different disciplines, and why USC is unique because USC has a pharmacy school, has a
Right.
chemistry department, has a marine biology department, has a sustainability institute. All of these are have to work together in order for us to succeed.
That's important. And I like the fact that the collaboration brings forth such amazing results. Can you give us an example of the technology being um, applied to like real life or?
Right.
Mhm.
So that's what this NOAA grant is now we're actually doing two things. One is we successfully made these blue dyes. So now instead of indigo, you're going to make these using your genes will come from the dyes from the plastic, right?
Mhm.
And then we're also working on like consumer products,
Mhm.
consumer enzymes that we're gonna make from plastics. So these organisms are already well known to make enzymes. So we're actually feed plastics to make these consumer products.
What other consumer products are there
Yeah, like for
that
example, laundry detergents, right? Think
Mhm.
about laundry detergents needs enzymes
Right.
to get your clothes clean.
Mhm.
Those enzymes actually come from fungi.
Okay.
So instead of just growing them on glucose, now we want to grow them on marine plastic. So we're not there yet, but we hope that in the near future you can buy your laundry
Mhm.
where the enzymes are powered from the plastics.
So on my laundry detergent, it won't say plant-based, it'll say plastic-based?
Yep. Yeah, it'll be
That's
better
funny.
than plant-based.
It'll be better than plant-based, that's funny.
Because plant-based is great, but plastic has no use right now,
Right.
right? Especially we're working with like styrofoam, 99% not recycled, right? So we want
Yeah.
to make from styrofoam,
That's great, and I mean, like, save our plants, like
right? And we believe that as consumers, you will be willing to pay a little bit more if you know what you're doing will take away the plastics from the ocean and clean up the ocean. It might be a little bit of more cost, but there's a lot of benefit from it.
Yeah, and that cost kinda, like, offsets the reward in so to speak, I'm paying a premium to keep my earth, going well, I'm paying a premium to clean up the ocean, I'm paying a premium to use plastic, and I'm paying a premium to save our plants, save our animals, and things like that. So I think it's like a no-brainer, like, it's like, yes, I would choose this over this, any day. And so how do you foresee this technology evolving over the next decade?
So I think one of the things is I could clearly see there's now a movement where there's a lot of interest in research.
Mhm.
So we're one of many groups to do this. So we really think that um, um, this plastic area will get to a point where first we're going to have better plastics that are potentially more recyclable, and
Mhm.
second, more methods to recycle the plastics. So I think the outcome
Mhm.
would be less plastic in landfills and more of that plastic somehow being used to make things that consumers can buy and use. So I
Okay.
think right now plastic are just used as containers,
Mhm.
but we can really think of it as ways to then be a source to make things that are useful for us.
Right. I mean, I would have never thought that breaking down a molecule can allow you to create an environment to grow, enzymes or
Right.
drugs or things like that. So that's very interesting. So I wanted to talk about your space initiatives and the things that you've been doing with regards to the fungi you spoke about and space. And so what exactly is this fungi? Like, what's the purpose of doing this in space? What is the
Okay,
environment of
so
space?
there's many aspects about microorganisms. So there's for our lab, there's two main reasons. Okay, so why are we going to Mars? We're going to Mars to see whether there's life in Mars. We want to go to Venus or go to the moon. One of the first thing is, are there something out there?
Hmm.
So one of the problem is if we get there, we want to make sure when we go to Mars and collect something, we're not collecting some bacteria that came from Pasadena.
Okay.
Okay. So every single
Uh,
organism, every single spacecraft
mhm.
that has ever left this planet are completely cleaned as much as possible to make sure that we don't contaminate them,
Got
the
it.
other planet. And that group is called the Planetary Protection Group. So we work heavily with the Planetary Protection Group. And what they do is any Mars rover that goes to Mars, they go and clean up as much as possible and they document what organisms live on the actual Mars rover.
Mhm.
Okay. So if Mars comes
I
back,
see.
they can say, it's got bacteria. Oh, that came from Pasadena.
Understood.
Okay,
That
so
makes
there's
sense.
that part.
Mhm.
And because of that, we've been studying the microbes that are on the International Space Station and we bring them back. So that's one,
Mhm.
okay? But for our lab, we're interested in medicine as you know.
Right.
So if you think about what the future is we're not going to just be living on this planet. We're going to be living in an International Space Station. We're probably going to be stationed in the moon. We're going
Mhm.
to be stationed in Mars. Okay. So if you're outside of Earth, right now, all the medicines are made on Earth, delivered to you in a space station. And that's not that bad because there's a monthly supply ship to go to the space station. But if you're living in Mars, that's
Hmm.
a year away. You can't deliver everything to Mars. So what
Right.
happens if you're sick and you need Alka-Seltzer? You're sick, you need like, you know, Benadryl.
Hmm.
You can't like have them delivered to you a year later. You got to have ways to make them outside of Earth. And that's what we're interested in is we're interested in making drugs outside of Earth, and we're using microorganisms to make them, which
Got
is
it.
the easiest way.
Hmm.
Yeah.
I am a huge sci-fi junkie, and
Hmm.
so this really just ignites the fire in my little heart about like the sci-fi, because you read a lot of these books and this is what they're doing. Like, Martian spoke about, he had a whole thing about growing, plants, and he was
Hmm.
harboring bacteria and doing
Hmm.
all these things. And it's just interesting to see how art imitates life in this way, and that these are the things that are actually coming to fruition. So it's really, 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 really cool. And so I know you said that you mostly did this because of your son, but I wanted to see if you could elaborate on how did the opportunity to conduct research abroad, the International Space Station, come about? I know you said that you saw it on campus, but was there any other
Okay,
factor?
so this is where proximity there's a lot of advantage, right?
Mm-hmm.
So people think of LA as, the entertainment capital with Hollywood, but we're actually also where Jet Propulsion Laboratory is
Mm-hmm.
at NASA. So if you think about all these great unmanned craft that leaves Earth and goes to outer planets, they're actually from LA.
Mm-hmm.
So JPL is just next door. So
Oh,
we
okay.
basically reached out to our colleagues at JPL and collaborate with them and work on the projects.
Oh, that's great. And so I want to touch back onto what you said about Mars and like it taking a year to get your medication. So how does the microgravity environment of space provide that unique environment to do this research?
Okay, so one of the things that we want to test
Hmm.
was, does it make a difference if you're in a microgravity um, for these microbes? Okay, so in a wild type strain
Hmm.
in microgravity, our data doesn't seem to make a difference. What's different is that on Earth, there's radiation protection from the ozone, but on space, there's no longer the ozone, so
Right.
they're under a lot of radiation effects. So
Oh, okay.
we do see effects of the radiation,
Hmm.
but in terms of production, we don't see that much difference. So
Oh, wow.
so we basically can make molecules by fungi on space, as well as on Earth, and that's actually great.
Yeah.
That just means that if you want your penicillin, you grow your penicilliums outside of Earth, they'll just make penicillin, right?
Hmm.
So it's really simple, and I think that's one thing that is a hallmark of our research is we would like to think of simple ways to solve questions that have broad impact.
That's amazing. And I just think it's so cool what you're doing. I don't think a lot of people have the opportunity to speak with somebody who's so directly involved with this type of research. So it's very nice to have this conversation with you, especially as someone who enjoys reading sci-fi and is a super nerd. But how has this opportunity developed any new methodologies or technologies as a result?
For ours?
Yeah.
So you mean for the space part?
Hmm.
Okay, so we are interested in these microorganisms, right? So what we have done is we collected some of these organisms that have lived in spacecraft for a while on the station.
Hmm.
And what happens is in the space station, there's actually a lot more radiation than they have on Earth.
Right.
So the organisms can actually adapt to that. Okay, so for example, we actually know what the radiation condition is on Mars.
Hmm.
So let's just take a typical organism like fungi or bacteria. They die within 30 seconds of the Martian conditions. But if the fungi that's isolated from the space station, they can live for 30 minutes because they figure out ways to counter that radiation. So one of the things they counter are they make molecules that can like absorb the radiation and NASA has actually licensed some of these compounds as skin products.
Mhm.
So people can use, you can buy cosmetics made out of metabolites that's made by organisms that came from, isolated from the space station, with the ideas that that will also absorb the radiations, be
Ah,
protecting you from the skin. Because one of the things that people don't realize is there's actually a lot of radiation the astronauts will encounter if they go to Mars and
mhm,
back. So NASA needs to figure out ways to kind of like protect them.
mhm.
And some of them are those going to be some natural product made by these organisms.
That
So
is
yeah,
great.
so
Yeah.
you can buy really nice cosmetics. I don't, but you could to do that.
I mean, I would just spend it just to see if it's something that would actually work better than, I guess, sunscreen.
Essentially, think about sunscreen. It's like super sunscreen.
Oh, okay.
Okay, so they have to have really good sunscreen because NASA really cares about sunscreens.
Mhm.
Okay, because the single trip from Earth to Mars and back, the astronaut currently will encounter in that one trip
Mhm.
enough radiation as much as the lifetime allowance of a nuclear power plant worker. Is that's how much that single trip is. Because every single
Wow.
nuclear power plant worker, as you know,
They have the monitor.
monitor. Just like when you do any radiation, they monitor that. But the whole allowance for the whole lifetime, they'll use it up in one trip.
I'm sorry. I am just astonished at both the fact about astronauts using sunscreen and about that tidbit that you mentioned. That is insane. I know you spoke about the microorganisms and the environment of space, and them growing is similar to what we can do here on Earth. But how does the radiation, how does those drugs with radiation affect us who've lived on Earth forever?
Okay, so I think the better question would be,
Hmm.
so Earth has ozone protection, right?
Okay.
So the organisms that live on Earth are protected from that, but in space they don't have that anymore. So
Hmm.
then they select from evolution. They select organisms that can live better out in space. But on Earth there are two places that actually have high radiation too, and we actually study those,
Hmm.
which you might not know. One, we study microbes that are isolated from nuclear power plants, specifically
Oh.
from Ukraine.
Hmm.
So before you were born, there was actually a nuclear disaster in the Chernobyl accident
Yeah.
and it exploded, right?
Hmm.
So people thought, oh, that's super high radiation. Nothing's going to live. No, they're actually
There's
have
animals that
organisms.
have adapted.
They have fungi that adapted by
Yeah.
living on the power plant. So we studied those and understand how can microbes survive in such high radiation.
It's such a devastating thing that Chernobyl occurred. But, I think the silver lining is the fact that because of this, we now can do research on the radiation, how those plants have adapted to that said radiation, and how we can maybe use that for
Correct.
our own needs.
Right.
So I think that's great. I think you're doing amazing. I think would be too little of a word to describe the research that you're actually doing and the importance that it has on the environment. I mean, with the space, with creating drugs, with microorganisms, and the sustainability efforts that you're doing. I just want to give you the all the awards that you can that I can give you. I wanted to ask that if you could lead a project funded by these awards, what innovative approach would you take to combat marine debris? This is just like a throw around question, fun question.
Um, so you mean if you give me all the money I can get,
Yeah,
what would I
yeah.
do? I think what we have gotten this time from the government is already a large part of what we want to do.
Okay.
But going forward, I think there's a lot more things that you can think of that we want to recycle. Okay.
Yeah.
So one of the things we are currently recycling are your polystyrene, your styrofoams
Hmm.
and your plastic bags, right? But think of like what we're trying to do with sustainability. We are saying, okay, let's just start building large um, those towers to generate windmills to generate electricity.
Hmm.
Those very large towers, right? We're trying to recycle that. Okay,
Oh.
why is that whole thing
Hmm.
only has a lifetime of 20 years? And after 20 years, you actually had to landfill those. So we want
Oh.
to figure out ways to recycle those.
Hmm.
And part of it is made of carbon fiber, which we were going to recover, but then the actual matrix is actually made out of polystyrene, which is same thing as these foams for poly. So we want to basically make things out of those windmills.
That's cool. I did not know that they had a lifetime of 20 years.
Yeah, they do.
Why is that? I mean,
I'm not quite sure, but they will be, there's a lot of efforts right now to build all these windmills outside of LA, out in the ocean, right? Yeah, I think they're just like airplanes. You cannot last 100 years.
Got it.
After certain points, you have to bring it back and then put in the new ones.
Okay.
But it's like airplanes. The airplanes are actually, the aluminum airplanes are recycled to make aluminum cans, but then carbon composites for those new carbon composite airplanes are not recycled yet. And that's one of the things that we want to do.
Okay. We're just about wrapping up. I just want to thank you for taking the time to speak with us today. I did want to ask before you leave one last question. And it is, if you could implement one innovative, sustainable solution tomorrow, what would it be?
I think if we can immediately start selling jeans that comes from the blue dyes come from plastic, I think that's something that we're really excited about, because we really think there's a generation of consumers that'll be really into eco fashion.
That's me.
Yeah.
Thank you for taking the time to answer our questions, Dr. Wang. It's been nice having you, and it's been a great conversation.
Thank you.